Hi, today we're looking at Functional Skills Maths Level 1. This is the Training Qualifications UK exam board. We've got examination paper 5 and we're going to start with the non-calculator section. Question 1. Work out 0.08 times 10. Okay, so we've got 0.08 times 10, so we're making the number bigger. We've got 1 0, so we're going to move the decimal point by one place. To make it bigger, we're going to have to move it to the right, so we end up with 0.8. So we've got 8 tenths, whereas we did have 8 hundredths before. Question 2. Work out 8 squared. So 8 squared means 8 times 8. So we've got 8, 16, 24, 32, 40, 48, 56, 64. There we go. Question 3. Work out 8.72 plus 10.4. So we write the 8.72 with the 10 below it, lining up the units and the decimal point. This is a plus. So we've got something here, we can put a 0 as a placeholder. We've got something to add now. So we've got 2 plus 0 is 2. 7 plus 4 is 11. 1 carry the 1, bring the decimal point now. 8 plus the 1 is 9. 1, and nothing else, it's just the 1. So we get 19.12. Question 4. Round 68.456 to the nearest whole number. Okay, well, that's the whole number part. So we look at the digit after the decimal point, which is the 4. If it's 5 or less, well, then we just cross it out. So we end up with 68. If this had been 5 or more, we'd round up to 69. Question 5. Work out 12 plus 10 divided by 2. So we've got 2 different operations happening here. We've got to think of our order of operations, and we always do division before we do addition. So we need to do this bit first. Well, 10 divided by 2, we've got 2, 4, 6, 8, 10. So that's 5. So we can replace this with 5. So this is equal to 12. We haven't changed to 12, so it still stays there. What we have changed is the 10 plus 2, which is now 5. So we've got 12 plus 5. Let's write this as a column. We don't have to. You could just take the 12, count on 5. 2 plus 5 is 7. 1 plus nothing is 1. So we've got an answer of 17. Question 6. Put these fractions in order, starting with the lowest. Okay, so with these, there's a few different ways that we could do this. The way I'm going to do it is to give them all a common denominator. So I'm going to look for a number that 8, 4, 3 and 12 all go into. Well, 4 goes into 8, so whatever 8 goes into is going to be fine. We've got to think, well, 3 goes into 12, 3, 6, 9, 12. So really we're looking for a number that 8 and 12 go into. Because if we can find that, it's going to work for these two as well. Well, I'm going to go through the 12 times table and see when 8 fits in or goes into it without any remainder. So 8 goes into 12, but we would have a remainder. 2 lots of 12 is 24. Does 8 go into 24? We've got 8, 16, 24. It does. So what this means is we can rewrite all of these fractions as being over 24. We know that 8, 4, 3 and 12 go into 24. Well, how many times does 8 go into 24? Well, we said 8, 16, 24. That's 3 times. So we need to multiply the top by 3. 3 5s, we've got 5, 10, 15. So these are equivalent fractions here. 5/8 and 15 24ths. Okay, what about 4 into 24? Well, we've got 4, 8, 12, 16, 20, 24. That's 6 times. So we're going to multiply the 3 by 6. 6, 12, 18. Okay, now what about 3s into 24? We've got 3, 6, 9, 12, 15, 18, 21, 24. That's 8 times. So we need to multiply the top by 8. And 2 8s are 16. Now for the last one, 12 to 24. Well, it was 12, 24. So 2 12s are 24. So we need to multiply the numerator, or the 7, by 2. 2 7s are 14. So now we can compare them directly. They've all got the same denominator, so we just look at the numerators. We want to start with the lowest. Well, what's the smallest number on top? Well, it's the 14. So this is going to be the smallest. Then 15. Then 16. And then 18. So writing them on here. Number 1. Well, let's go back to the original fractions they gave. So it's 7 12ths. The second one is 5/8. The third one is 2/3, and the fourth one is 3/4. Question 7. Convert 12,500 grams into kilograms. Well, I know there's 1,000 grams in 1 kilogram. So if we're going from grams to kilograms, kilograms are bigger, so we're going to have fewer of them. So we need to divide 12,500 by 1,000. So making it smaller and by 3 places. So if we think the decimal points at the end, we're going to move it 1, 2, 3 times into here. So we get an answer of 12.5. And we don't need the zeros. We could put 0.500, but that's not required. It wouldn't be wrong, but I'm just going to leave it out because we don't need to. Okay, question 8. Stevie sells homemade items online. The table shows the amount Stevie made in sales each month. So January we had £1,200, February £800, March £1,180, April £1,575, May £1,430, and June £1,350. Stevie thinks the range of these amounts is more than £1,000. Is Stevie correct? Well, the range is the biggest number minus the smallest, or it's the difference between the biggest and smallest number, and we find out what the value is by subtracting one from the other. So what's the biggest number we've got? 1,200? Anything bigger? Yeah, 1,575. So that's our biggest. Nothing bigger than that. And what's the smallest one we've got? 800, I think. Yeah. So for the range, we're going to need 1,575 minus 800. Again, we lined up, so we've got the units, the tens, the hundreds land up above each other. 5 take away 0 is still 5. 7 take away 0, or nothing, is still 7. 5 take away 8, we can't do that. So we're going to take 1 from here, reduce the 1 by 1 to 0, and make this 15. You could have just kept it as 15, but a lot of people like to think of it as passing it over, so we've now got the 15 minus 8, which gives us 7. Okay, Stevie thinks the range of these amounts is more than 1,000, while 775 is less than 1,000. So is Stevie correct? No. Question 9. Aya is making a sculpture out of a block of ice. The block of ice is in the shape of a cube with a side length of 25 centimetres. Aya thinks this is over 15,000 cubic centimetres of ice. Is Aya correct? Show how you decide. So I'm going to draw a quick sketch of this. We're told it's a cube. So if we think of that, a square front face, we'd have a side going back and we'd have the top. And because it's a cube, the face is going to be 25 centimetres across. It's going to be 25 centimetres deep, and it's also going to be 25 centimetres high. Okay, so to know how much ice we've got, we need to work out the volume. And the volume, if it's a cuboid, it's the length times the width times the height. But here, because it's a cube, they're all the same. 25 times 25 times 25. Or you could say 25 cubed. Okay. And then we're going to try and compare that to 15,000. So let's do this. Let's multiply 25 by 25 to start with. 5 times 5, 5, 10, 15, 20, 25. 5 carries a 2. And then 2 times 5 is 10. Add the 2 is 12. Now we move on to the 10, so we can put a 0 in the units. 2 times 5 is 10. 2 times 2 is 4. Plus the 1 is 5. Add these together. 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 5 is 6. So we've got 25 times 25 is 625. What we now need to do is multiply it by another 25. So we've done this bit. We need the extra 25. So 625 times 25. Now there may be other ways of doing this. You could treat it like a division, which is actually quite a nice way of doing it. What you could do now is divide the 15,000 by the 25. But I'm going to continue multiplying and then compare it to the 15,000. So 5 times 5, we saw before that was 25. 2 times 5 is 10, plus the 2 is 12. And 6 times 5, 5, 10, 15, 20, 25, 30. Add the 1 carried, that's 31. Now move on to the 10s. Put a 0 here. 2 times 5 is 10. 2 times 2 is 4, plus 1 is 5. 2 times 6 is 12. 5. So add these together. 5 plus 0 is 5. 2 plus 0 is 2. 1 plus 5 is 6. 3 plus 2 is 5. 1 on its own is just 1. So we get a total of 15,625, which is greater than 15,000. Aya thinks this is over 15,000 cubic centimetres of ice. Is Aya correct? Yes. They're correct. And that's the end of the non-calculator section. So now we move on to the calculator section. Okay. Jang has 260 books and wants to give 5% to a charity shop. How many books should Jang give to the charity shop? Okay. You could do this without a calculator, but remember we're in the calculator section now, so we might as well save time and go straight for 5% being 5 out of 100 of 260, so that is going to be times 260. So 5 divided by 100 times 260, we get 13. Question 2. Use this rule to convert £500 into Japanese yen, Japanese money. So you take the British pounds, you multiply it by 167, and you get the amount of yen. So 500 times 167. So again, we can type this straight into the calculator. Do it on here so we can see 500 times 167, and we get 83,500 yen, and we can put that in our answer box down here. Okay. Question 3. Work out how many centimetres there are in 3.7 kilometres. Right, well, I'm going to do this bit by bit. So instead of going from kilometres straight to centimetres, I'm going to go from kilometres to metres. And I know that we've got 1,000 metres in 1 kilometre. So I'm going to take my 3.7 kilometres and multiply it by 1,000. So 3.7 times 1,000, we get 3,700. That's now metres. Now I also know we want to go from metres to centimetres now. I know we've got 100 centimetres in 1 metre. So if we multiply this by 100, we should get the number of centimetres. And we've got 370, and there's our comma. They put the comma up at the top to 370,000 centimetres, which we can write down here. Question 4. Let's move it up a little bit. Baraka wants to buy a new coat. Baraka sees the same type of coat for sale in 2 shops with the same original price. Shop A, the coat has now got 18% off. Shop B, the coat is now 1/5 off. Which shop is offering the bigger discount? Well, we want to know what's bigger, 18% or 1/5. We want to get them both in the same type of units, really. So what we can do is convert the fraction into a percentage. And the way we do that is we do the 1/5, multiply it by 100. So 1/5 literally means 1 divided by 5. We then multiply it by 100, and we get 20%. So the bigger discount is going to be the bigger percentage, which is this one. So we want shop B. Question 5. Kim puts 48 tiles on the wall in a bathroom. This is 1/6 of the total number of tiles that need to be put on the bathroom wall. How many tiles does Kim need to put on the bathroom wall in total? So if this is 1/6, think of it like this. If we split this up into 6 sections, 1, 2, 3, 4, 5, 6. And they're saying 48 is 1/6. So that must be that all the others are 48 as well. So if we want to know the total, well, basically we want 6 lots of 48. So 6 times 48 gives us 288 tiles. Question 6. Jessie is planning a trip to see a friend. The train ride will take 210 minutes. It then takes a quarter of an hour to walk to Jessie's friend's house. What is the total time needed for Jessie to complete the journey? Well, a quarter of an hour is 15 minutes. If you're not sure about that, then you can think, well, there's 60 minutes in an hour, and we just do a quarter of 60, and we do it that way, which you can use your calculator, but it's going to give you the same answer. So if we want the total distance, or total time, it's going to be the 210 minutes for the train ride, plus the 15-minute walk. Plus 15, which gives us 225 minutes. Now, if you want to turn that into hours and minutes, you can do, but they haven't asked you to, so you would just be creating extra work for yourself. If you look in the answer box, it doesn't say hours or minutes. So long as you say what the units are, it's fine. Okay, so I'm going to leave it in minutes, and we can stick with that. Okay, question 7. Draw a triangle which has exactly one line of symmetry. Show the line of symmetry on your triangle. So this is an isosceles triangle thereafter. Doesn't matter if you don't know the exact name for the triangle, that's fine. But I know that means I'm going to want two lines which are the same, or I think of it as two angles being the same. So the way I'm going to draw this triangle is, I'll pick a random base. I'm going to make it 4 centimetres across. I'll find my middle, which would be 2 centimetres, and I'm just going to draw a line. Well, not a line, I'm going to put a dot right above the middle. So now if I join these two together, I'm not measuring them, but I know because of the way I did it in the middle that these two angles are going to be the same, which means that these two sides will be the same. Therefore, I've got my isosceles triangle. So if I then draw a line down the middle, it's got exactly one line of symmetry. Okay, something that looks roughly like that. What you want to be careful of is that you don't accidentally draw an equilateral triangle with all three sides the same length. Because if you did, you'd have a line of symmetry down that way, but you'd also have one there and one there. So it wouldn't be exactly one line of symmetry. Okay, so that one's no good. You want something like this. It doesn't have to be long and pointy. It could be like a short, fat one like that, and still have the line of symmetry down the middle. I should have done that with a ruler first off. Okay, so there's different ways, but it's probably easy to think of it as something looking like this, a tall triangle. Question 8. Anan has a packet of 120 carrot seeds. On the packet it says approximately 1/15 may not grow. That may not grow. How many carrots will Anan have if 1/15 of the seeds do not grow? So what we can do is we can work out 1/15 and take it away. So 1/15 of 1/15 times 120. Right, now what we can do here, if we just type it straight into a simple calculator, 1/15 times 120, you'll see we've got a number that with lots of decimal places. We can round it to 8, but it's a little bit messy. The way around that is if we do the 120 first, 120, and then multiply by the fraction, so times 1 divided by 15, and we get a nice tidy answer of 8. So that's the ones that do not grow. We want to know how many will grow, so we need 120 minus the 8. So 120 minus 8 gives us 112. Now another way to do it, bit of a shortcut, is to say, well, if 1/15 don't grow, then that means that all the rest do grow. So 14/15 of 120 do grow. So again, the way we could do this is say, well, actually work out 1/15, so 120 divided by 15, and then multiply it by the 14 to give us 112, which is what we've got here. Question 9. Ty is making a box from a piece of card. The diagram shows the net of the box. The height of the box must be 2 centimetres. Work out the volume of the box. Okay, so here's our net, and they told us that the height is 2 centimetres. So that's going to be this distance here, and this one as well, actually, if you imagine the box being sort of folded up. So 2 centimetres. So let's just draw what the box is going to look like. We'll have this bit here at the front, and then it's going to go back like a rectangle, and we'll have these. So this will be the front, these will be the side bits, and then we've got the base. It might not have a top. It looks like it might be an open box, but that's fine. And I'm just going to do dotted lines to see what it would look like. Okay, something like that. Now, we've got the distances or the measurements on here. What we've got to be careful of is 10 centimetres isn't this length here, because we've got these two bits on either side. So we've got 2 centimetres here and another 2 centimetres here. So actually, this distance in the middle is going to be 10 minus 2 and minus another 2. So 10 minus 2 minus another 2 leaves us with 6. And you can do that because 2 plus 6 is 8, plus another 2 gets you 10. So we've got 6 centimetres across. And the reason we're trying to work out these measurements is we want the volume, and we know that the volume of a cuboid is the length times the width times the height. So if we can work out what these measurements are, we then just do that calculation. We know the height because we know that this is 2 centimetres. They've told us that. So now what we want is this other distance going back. So in other words, we want this length here. We know it's 11 centimetres all the way up. And because we've got the height as 2 centimetres, that means that this bit is 2 centimetres. And this bit is 2 centimetres. So again, we can take the full length, which is the 11, minus 2, and minus another 2. And if we want to use the calculator for this, 11 minus 2 gives 7 centimetres. Okay, so we've got our 3 dimensions now. So the length, well, let's say that's the length of the 7. The width is a 6. The height is the 2. 7 times 6 times 2 gives us 84. And that's 84 centimetres cubed. And we can then write that in our answer box down here. Okay, question 10. Tommy's car uses 6 litres of petrol to travel 120 kilometres. A full tank holds 40 litres of petrol. Does Tommy have enough petrol in a full tank to travel 700 kilometres? Okay, right. We can do this in 2 ways. We can either focus on the litres and work out how much distance you can travel with a full tank of 40 litres, or you can look at the distance and say, well, how many litres would I need to travel this distance? What I'm going to do is I'm going to focus on the litres, and I'm going to say, well, if 6 litres will allow you to travel 120 kilometres, so actually I'm going to draw a quick TQUK table. And I'm going to have my litres and my kilometres. So 6 litres allow me to travel 120 kilometres. What I want to know is, well, how far can I travel if I only had 1 litre? And to get from 6 to 1, you're just dividing by 6. So I'm going to do the same on this side. So 120 divided by 6 is 20. So if I had 1 litre, I could travel 20 kilometres. I've got 40 litres. So, to find out the distance we can travel, we multiply that by 40. I'm just going to extend this line down a bit. So we want 20 times 40. Still got the 20 in there, times the 40. If we had 40 litres, we could travel 800 kilometres. Does Tommy have enough petrol in a full tank to travel 700 kilometres? Or 700 is less than 800. So we can say 700 less than 800. So, yes. And that's enough. I'll answer on that one. Question 11. Bailey is planning a road trip. The total distance is 2,018 miles. Bailey will drive 25% of the distance. How many miles will Bailey drive? So the distance, 2,018. So we've got no hundreds. So 2,000, no hundreds, 110, 8 units, 2,018. 25% of it, so we want 25 out of 100 of, or times, 2018. And we get 504.5, and that's miles. But they have said, give your answer to the nearest mile. So we've got to round this. These are our miles. Remember, if this is less than 5, we'd just keep it as 405. If it's 5 or more, we need to round it up to 505 miles. Question 12. A gym asked their customers to share their favourite exercise. This table shows the results. So 12 people said deadlifts were their favourite exercise, 18 people said squats, and 6 people said arm curls. Show this information in a pie chart. Right, well, we've got the numbers of people. If we're doing a pie chart, we've got to work with angles. And the total number of angles or degrees in a circle, because it's a pie chart. In fact, let's quick look at the blank pie chart we've got here. Total number of degrees we've got are going to be 360. And hopefully you'll see, there's a bit of a pattern here. It's the same, but with a 0 on the end. So in other words, it's 10 times bigger. So we just need to do the same with all of these to get our number of degrees. So times the 12 by 10, times the 108, the 18 by 10, times the 60 by 10. And when we're multiplying by 10, we just put a 0 on the end. So 120, 180 degrees, and 60 degrees. Now we've got to plot that on our diagram. Now, because one of them is 180 degrees, the squat, so I know that 180 degrees is half a circle. So I'm actually going to continue this down, and then we can just say, well, this is our squats on one side. Okay, then I only need to do one measurement on the other. So for deadlifts, we've got 120 degrees. Right, so we need our protractor for this one. So I'm going to measure it on this side. So this is our centre of the circle, to put the crosshairs on there. Now it doesn't matter if you start from the top or bottom on this one, so long as you're consistent with which way you do it. What should we do? Let's start from the bottom. So we'll start with a 0. So 0, 10, 20, 30, you go all the way around until we get to 120, which is up here. So now we can just connect that. Now the 120 is the bigger one, so this is our deadlifts, and the last one must be the arm curls. So if you've done them in a different order, it doesn't matter. I've done it this way just because it was easier to get my 180 straight away. Question 13. There are 60 members of a sports club. 17 people play squash in total. 5 people play both tennis and squash. 20 people do not play squash or tennis. Use the Venn diagram to work out how many members play tennis. We've got a number here 20, which means there must be 20 people that don't play squash or tennis. 70 people play squash in total, so that's going to be the ones in here that play only squash, plus the ones in the middle that play both. So I'm not going to do anything with the 17 just yet. 5 people play both tennis and squash, so that can go in the middle. Now I can use this, because if we know 17 people in total play squash, the ones that only play squash must be the 17 minus the 5 that play both. Again, you probably don't need a calculator for this, but 17 minus 5, we get 12. So play only squash is 12. Now, we want to know how many play tennis, or only tennis. Well, we know there's 60 people in total. 20 don't play a sport at all. So if we think 60 minus 20, $40 must play either squash or tennis. We know that 17 play squash, so if we take off the 17, this is going to leave us with the ones that play only tennis, which is 23, which we can put in here. Okay, now they've said use this Venn diagram to work out how many members play tennis. So the number of members that play tennis will be the 23 that only play tennis plus the 5 that play tennis and squash. So if I move this down, so what we want is the 23 plus the 5. Then you can use your calculator to give you 28 members. Question 14. Chen has £125 to spend on books and travel in the ratio 1 to 9. That means every time he spends £1 on books, he spends £9 on travel. The book Chen wants costs £19. Today, there's a 35% discount on the book. Can Chen afford to buy the book today? Okay, so what we want to do first of all is work out what the new price of the book is. So 35% discount on the book. So let's work out what this discount is. It's 35 out of 100 of £19. 35 divided by 100 times 19 gives us £6.65. That's the discount. So if we want to work out the new price, take the original, the £19, and subtract the £6.65. 65. Let's put this in my memory. So we can do 19 minus memory recall gives £12.35. Right, okay, so what we can do with this one is, well actually, what I'm going to do is I'm going to look at this ratio. I'm going to draw a bit of a ratio table. And in my ratio table, I'm going to have books, travel, and total. And if you can't see what to do with the question straight away, don't worry. As soon as you see ratio, think ratio table. Put the values in, and then hopefully you'll start to see a potential solution or some method of working things out. So we know we've got the ratio of books to travel is 1 to 9. If that's all we had, well, 1 plus 9 would be 10 in total. We've actually got £125 in total. So I want to think, well, how many of this top row can you fit in there? And the way to do that is to work backwards. Do the 125 divided by 10. And if you do that, it's 12.5 or 12.5 times. Okay. Now, so if we did that, that means the books, 1 times 12.5 would just be 12.5. Or to think of it as money, it would be £12.50. So you can afford £12.50 on books. The price of the book is £12.35. So we can say, well, £12.50, which you can afford, is more than the £12.35 that he needs. So can he afford the book? Yes, he can. And the last question in this paper, question 15. The scale diagram shows the position of Aid, a tree, and a gate. Aid is facing the tree and wants to walk to the gate. Use the distance to the gate rounded to 1 decimal place, the angle of direction Aid should turn, and the distance to walk to the gate. So let's shift this up so we can see a bit more here. Okay, and so that question was, how does Aid get to the gate? Right, so we've got Aid down here. So the things that it said to use were the distance to the gate rounded to 1 decimal place. Well, here's Aid, here's the gate, so 9.45. To 1 decimal place, well, the first decimal place would be the 4, so we look at the digit after it. Remember, if it's 5 or more, we round it up. So we're going to round that, increase that by 1, so we're going to round that to 9.5 centimetres. That's the first bit. Then it says it wants the angle of direction Aid should turn. He was facing the tree, so looking up this way. The angle to turn is going to be this angle here. So I'm going to get my protractor out. Line the crosshairs up here. So if we start on a 0, we're measuring this angle here. 10, 20, 30, 40. It's exactly 50 degrees. And they want the distance to walk to the gate. Okay, so, well, we know 9.5 centimetres is on the drawing, but it says 1 centimetre represents 100 metres. So if we multiply this by 100, that's going to be 950 metres. So, what was the actual question? How does Aid get to the gate? Okay, so, oh, there it is, right. How does Aid get to the gate? We've got all our information, we've worked everything out. So I would just say, turn clockwise, we want to go this way. So turn clockwise 50 degrees. And walk 950 meters. Okay. And that's it. So that's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I load more videos. And I look forward to seeing you again soon. Thank you.